Alrighty. So this is going to be our last part of continuity, and this is going to be our first big theorem in the course, aka the intermediate value theorem. We'll talk about MVT and EVT, and then we'll mix it up with IVT later down the road. You don't need to know what EVT and MVT is yet, but later we'll mix everything up, which is going to be a lot of fun. But with IVT here, if f is continuous on the closed interval a to b, and f of a is not equal to f of b, and k is any number between f of a and f of b, then there's at least one number c in a to b such that f of c is equal to k. Now this is a lot of mumbo jumbo, but essentially, we'll look at number 5. Essentially here, we're going to be using the IVT to say that, hey, there's going to be some number between 1 to 2 such that there's a 0 here in this case, or 2, or 3 for these problems. So to prove the intermediate value theorem, we're going to need to do a couple of things. The first thing that we're going to do is prove that the function's continuous. Usually it's going to say that the function is continuous, or you need to prove that's continuous because, hey, it's a polynomial function, just like number 5. So here, I'm going to say that f of x is continuous on 1 to 2 because f of x is a continuous polynomial function. Great. So that's our first part. Our second part is finding out what my f of a is and my f of b. So in this case, I need to figure out what f of 1 is, and I need to figure out what f of 2 is. Now, using my handy-dandy calculator, aka Desmos, I know that f of 1 is equal to 2, and f of 2 is equal to -10. See how there's a 0 between 1 and 2? Now, do I want to know what the 0 is? No, I don't really care for that value. I only care about, hey, there's going to be a 0 between 1 and 2. I just don't know what it is, and I don't care for now. So we have 2 and -10. So I could say that f of 1 is 2 and f of 2 is equal to -10 for my second part. Now I have 2 -10. I just have to explain to myself that these values are between, well, 0 is between these two values. So I'm going to say that f of 2 is less than or equal to 0, which is less than or equal to f of 1, because I have -10 is less than or equal to 0, which is less than or equal to 2. So because that's true, and f of x is continuous on 1 to 2, there exists a value c such that c is between 1 and 2, such that, obviously it can't be 1 and it can't be 2, such that f of c is equal to 0 by the intermediate value theorem. Or you can abbreviate by saying IVT, which the graders will understand. All right, we're going to do the same thing here for number 6, where we have, let's see, a car travels on a straight track, and it says that it's a continuous function of time, and it says that, hey, we have selected values of this function for 0 to 60. Must there be a time t when v of t is equal to 2, and we want to justify our answer. So here, we already know that v of t is a continuous function of time for 0 to 60. Then we're going to look at 0. That's going to be negative 20. And 60, that's going to be 10. Once we get those values, we know that 2 is definitely going to be between negative 20 and 10. So I'm going to write that inequality and say that v of 0 is going to be less than or equal to 2, which is less than v of 60, because negative 20 is less than 2, which is less than 10. And v of t is a continuous function. There exists a value t such that t is between 0 and 60. The value of t between 0 and 60 such that v of t is equal to 2 by IVT. Okay, last one. Selected values of the continuous function f are given below. So we know that f of x is continuous. So that I could say f of x is continuous on negative 5 to 4. Then if I were to look at f of negative 5, that's 7. And f of 4 is 0. Now, 3 is definitely between 0 and 7. So I could say that f of 4 is less than 3, which is less than f of negative 5. Then I could say that and f of x is continuous. There exists a value c such, well, c, and then we're going to say that value between 1 and 1, c between 5 and 4, such that f of c is equal to 3 by IVT. Yay. All right, in our next video, we'll talk about advanced limits, and then we'll talk about vertical and horizontal asymptotes.